Alright, so in this question it says find the equations of the two tangent lines to the function y equals to 3x squared that intersect at the point -1, -9. Now, extremely difficult question if you don't sketch this out. I'm going to start with a sketch. I always recommend a sketch for harder problems. So I have a function y equals to 3x squared, quadratic function. I know that there are two tangent lines to this function that intersect at the point -1, -9, which is approximately there. So my first tangent line is going to look something like that, where this is the intersection point. And then my second tangent line is going to look something like that. So you have a second intersection point, and I know these 2 points over here intersect, or these two lines intersect at the point -1, -9. Okay, so now that I have my graph, I don't really need the question anymore. I can work from this graph. What I'm going to start doing is I'm going to call this point right here point number 1. So that's x1, y1. And this point right here is my x2, y2. So basically this is my line 1, and this is my line 2. The first thing I'm going to do is I'm going to start working with this point right over here. So at point 1, I know that at point 1, I have an equation of a straight line, and then I have an equation of the quadratic function, and they intersect at that point. So my equation here for point 1 for my straight line would be y1 equals to m1 x1 plus b1. And my equation for my quadratic function would be y1 equals to 3x1 squared. I know that these two equations intersect, so I can equate them together. So m1 x1 plus b1 equals to 3x1 squared. So basically my linear equation and my quadratic equation intersect at point number 1. And then I have to find my m1. So I know that from the function y equals to 3x squared, I can find my slope by deriving it. So my m1 is going to equal to 6. x1, I've basically just derived that function. I'm going to sub my m1 back into this equation. So I have 6x1 times x1 plus b1 equals to 3x1 squared. And then I'm going to simplify this. So that's 6x1 squared plus b1 equals to 3x1 squared, which basically means my b1 equals to -3x1 squared. Okay, once I'm done that, I'm going to basically work on my line 1. So if I look back at my diagram, this line number 1, passes through the point -1, -9. So if I did the equation y equals to mx plus b for my line number 1, I know that the y value is -9. I know that my m, I found it to be 6x1. And then I know that my x is -1. And then my b is just going to be b1. I know that my b1, I found it from the previous point right here. So -3x1 squared. I'm going to sub that in, and I'm also going to simplify this equation a bit. So that's going to be -6x1 minus 3x1 squared. I'm going to bring this all to one side because it's a quadratic equation. So 3x squared plus 6x minus 9 equals to 0. And remember, these are x1s. Then I'm going to factor it. So 3x1 squared plus 2x1 minus 3 equals to 0. Factor again. So x1 plus 3. x1 minus 1 equals to 0. Basically x1 equals to -3, or x1 equals to 1. If I take a look at these 2 points right here, I go back to my diagram, I can tell that x1 is definitely going to be -3. So I know this one is -3, which basically makes my x2 equal to the other point of 1. The two solutions for x1 are basically a solution for x1 and a solution for x2. That's how it works in this question. Okay, so going back to my line number 1, I know that my x1 is equal to -3 and my x2 is equal to 1. Now let's actually figure out the equation for this line. So again, I'm going to start with y1 equals to m1x plus b1. Okay, and basically the first thing I want to do is I just want to figure out my m1. So I know that my m1 is 6 times x1, and I know my x1 is -3. So basically my slope of my first line is -18. So I basically have y equals to, oh, I don't need the ones over there, y equals to -18x plus b1. And again, I can sub in my point of intersection into this because I know this line passes through that point. And then I can solve this to find my b1. So -9 equals to 18 plus b1. -27 equals b1. I can rewrite my equation. So y equals to m1, so which is -18 x plus b1, which is -27. So I found the equation for line number 1 over there. Again, it looks like it's the right solution because as you see, the y-intercept is going to be pretty low in this function, so about -27 looks right. That's the equation of my first tangent line. Now all I have to do is find the equation of my second tangent line, which again is pretty simple at this point. I'm going to try and fit it in this little gap up here. So I know that my equation for my second tangent line is y is going to equal to m2x plus b2. Basically means I need to find my m2 and my b2. For my m2, it's pretty simple. I know, again, using the derivation, my m2, the derivation of 3x squared is 6x. So my m2 is going to equal to 6x2. And I know my x2 is equal to 1. So 6 times 1, which is 6. Sub that back into this equation. So y equals to 6x plus b2. And line number 2 also passes through this point, so I can sub this point in. -9 equals to 6 times -1 plus b2. -9 equals to -6 plus b2. -3 equals b2. Found my y-intercept. I know my m2 is equal to 6. So my equation for my second line is y equals to 6x minus 3. Now I found the equations of the two tangent lines to the function y equals to 3x squared that intersect at the point -1, -9.